Alright, this is Robert Ganzi from Alum's Lab TA group, and here we're talking about, this is our alum video number 2, percent yield. So, start off by taking a look at the crystals. So here are my alum crystals. Can I kind of make them out there? So, these crystals are being formed through slow evaporation of the alum liquid, which is forming a nice, crystalline structure. These ones are a little bit cubic, as you can make out. So the way these crystals are forming more specifically is now that there's a small crystal has formed, it's easier for other crystals to form onto that through the process of seeding. There's a little there's a site that they can all grow on top of, and that makes it easier for more crystals to form, and so they're forming larger, more structured crystalline structures. But let's talk about the percent yield for the alum. So we started off with 1.02 grams of aluminum foil, which and then we ended up with 24.25 grams of alum. So this is a 1-to-1 reaction. For every gram of aluminum we put in, we should get for every mole of aluminum we put in, we should get 1 mole of alum back. So that's through the whole process of reactions that we talked about in the last video. So now we're going to do some chemistry, some stoichiometry, and we'll see that 1.02 grams of aluminum, that's 0.03378 moles. So again, because we have it's a 1-to-1 reaction, that means the number of moles of aluminum we have is going to be equivalent to the number of moles of alum. So doing the math there, then we get that we have 0.0738 moles of alum. So then using the molar mass of alum, we multiply those two together, and we find that we get 17.93 grams of alum is what we would expect to have. But again, looking up here, we actually got 24.25 grams of alum, which is significantly over. So calculating our percent yield, the observed over the expected, we get 24.25 over 17.98, and we end up with 135.2% yield. Okay. So this is clearly extremely over. This is not really what we're looking for. Ideally, we want to be around 100 or just a little bit under, or something like that. So this means that there's something wrong, or something went a little bit wrong, and our data is a little bit off. So what are some explanations for why we are so significantly over? So one of the most logical reasons is when we were doing the experiment, we put the alum crystals through a wash of water and ethanol. It's very possible that a lot of the water in that wash stuck onto the crystals and didn't fully evaporate, which would lead to an increased total mass at the end. So one of our solutions for that could have been, if we left the crystals for longer, maybe if we let them dry for an hour rather than maybe the 10 minutes that we did, then they would have dried more, and then there wouldn't have been as much water on them, so there would be more of just the alum crystal and not just the water. And that might have lowered our percent yield. Another possible explanation is that there's some other impurities that weren't fully taken off with the wash, and that would also increase our percent yield, as there'd be other substances on top of it. However, these crystals look fairly pure, so I don't think that there were very many impurities, if any. There likely were, but that's alright. So anyway, this has been alum video number 2, Robert Ganzi. Here are the little crystals. Yeah. And I will see you next video.